All right, next step. Let's talk about AFUE and what it does for you and me. AFUE, and this is for furnaces, and it stands for, the AFUE stands for annual. What do I spell annual? How do you spell annual?
ANNUAL.
Oh, I was close. Just missed one in. Annual fuel. This marker is done.
Check if it has carbon monoxide.
Oh, by Kobe, because we need.
Yes, well, that's what your face is.
Annual fuel utilization efficiency, AFUE. AFUE.
So SEER, but not.
Yes, very good. What does SEER stand for? Seasonal energy efficiency ratio, right? So that's the rating of efficiency for air conditioners. And then we also have HSPF, which is heating seasonal performance factor, which is the rating for heat pumps in the wintertime. And now we have AFUE, which is annual fuel utilization efficiency for gas furnaces. It's the rating of efficiency of gas furnaces. It's our efficiency for gas furnaces. So the higher that number, the less fuel it's going to use to heat your house, right? AFUE, annual fuel utilization efficiency. So there's different types of these. We had standing pilots. Were anywhere from 40 to 60% efficient. That means of the fuel, of the natural gas that or propane that I bought, 40 to 60% of that went to actually heat the house. The rest of that heat that we paid for went out the flue pipe. Yep. The rest of the heat went out the flue pipe. Now, I had this the other day, and I told David, I said, David, I need to go home. I have the flu, and he wouldn't let me. So, just because you have the flu doesn't mean you get to go home. But what it really means here is the rest of that's how much is going into the heat. The rest of that heat that I paid that gas for is going right out this flue pipe, right out into the outdoors.
Is that a standing pilot?
Standing pilot.
Maybe we can sit down.
Yes. So then we went to an intermittent pilot or a direct spark ignition. Any of these other ones that we have now, hot surface igniter, direct spark. So we call it DSI for direct spark ignition or HSI for hot surface igniter. Most of the ones that we have now with the single heat exchanger are 80% efficient. 80% efficient. So this one here that we've been working with, all the ones we saw in the lab, they are 80% efficient. So that means 80% of the fuel that I buy is going to heat the house. 20% is going out this flue pipe. Notice it's right there at 80%. Now they started making them, I can't remember exactly what year it had to be 80%, but I think it was 1992. I think it was 1992. I can't remember exactly, but I'm pretty sure it was right around 1992 they did away with standing pilots. Did away with thermocouples. This is why I don't teach you standing pilots and thermocouples anymore, because it's out of date. This is 2018 now, right? If you have a standing pilot, that's going to be how many years old? 20 plus years old?
The system needs to be replaced.
Yeah, exactly. So,
Higher efficiency.
yeah, you need to, and in 20 years, even this really awesome heat exchangers that are made, they have lifetime warranties, and that's considered 20-year warranty. It's a lifetime of a unit. So if it's 1992, a standing pilot, it needs to be replaced. It really does. So I'm not going to spend all the time. It's going to take a lot longer to teach gas heating because I have to teach all these different types of pilots. If you see a standing pilot, out. Replace it with a new style. But all those, since then, it had to at least be 80% efficient. Now the country is divided between, there's sections of it. It's north, east, south, east, and then the southwest. I can't remember exactly how that is, but the AFUE divided it up. And most of the country, you have to at least have 80% efficiency units. But in the Northeast, it just so happens that the climate is cooler there. They don't need as much of air conditioning. But they do need more what? They do need more heating. So here we spend a good deal of our paycheck on cooling, on the electric bill side. And the Northeast, they spend a good deal of their money on the heating side, is paying the gas company. So up there, we want to have units that are more efficient. In other words, if you drove your car a few miles a day, is the miles per gallon of that car going to be as important?
No.
Not really. Now, if I drove, say, 100 miles a day, would the miles per gallon of that car be more important?
Yeah.
Yep. I want to be looking at something that gets a lot better mileage at that point. So if we're in the Northeast, we want something that gets better mileage. So they usually in the Northeast require units to be 90% plus, at 90% more efficient. So they're called 90 plus units. They're 90% or better, 9% plus. A lot of these units, when they become 90 plus, it requires a bit more technology. So in the Northeast, you may be required to have a 90 plus unit. This is a 90 plus unit I have right here. We're going to explain its components. This 90 plus unit, can you get one here?
Yeah.
Yes. It's just probably not going to pay for itself as quickly. You're not going to use it as much. Right? We use it that a few weeks out of the year. But in someplace else with a cooler climate, it's going to pay for itself a lot faster. Let's say Washington State.
Or New York.
New York, yeah. Get the bigger pizza, but then you have to, deal with your more heating. Okay? So 90 plus furnaces are also direct spark ignition, DSI, and HSI ignition, except they had to add some components to get the heat out of it. Now, on my typical heat exchanger, with this right here, I can get out of the heat, out of the gas that I burn, I can get 80% of the heat exchanged from the gas and flames to the air. Where does the other 20% go? Right at that flue pipe. So is this flue pipe going to be warm?
Yep.
It is, and it's very important. It actually needs to be warm. If my gas is in this flue pipe cooled off, would I have natural convection? No, the gases wouldn't be traveling out. I need this flue pipe to be warm so that it naturally drafts out. Actually, if you put your flue gas in a flue pipe that's too big, you won't be able to heat all that air, and you actually have a problem with your combustion and gases not leaving.
Also, if flue pipe had that, wouldn't it cause if the flue pipe is cold, wouldn't it cause the carbon monoxide to stick around more?
It would. The carbon dioxide would come down. That's exactly right. So it's important you have the correct size flue pipe.
If your flue pipe is warm, could you attach a vent to it and then put a blower across it and pipe that back into the house?
Let's talk about that. One of the byproducts of complete combustion is heat, right? And carbon dioxide, and what? Water vapor, H2O. So what's going to happen, though, is if I keep the temperature warm, I keep the H2O in vapor form. But if I cool the temperature of that gas down too much, if I ran this across at an angle where it still drafts across this room, and I put maybe heat exchangers on this, so I'm exchanging the heat of this pipe to the house, what's going to happen to that water vapor?
It's going to turn into a liquid.
It's going to turn back into a liquid. And all these other gases, like the nitrox, anyways, the nitrogen turns into mixes with some of the other unburned gases and turns into an acid. That acid starts running back down this flue pipe, it'll eat it away. And you get condensation. That condensation is going to run back in your heat exchanger, and it's going to rust out your heat exchanger. So I don't want to cool this off. I don't want to put anything else to exchange heat here. If I cool this off, the water vapor in the air is going to rust this out. It's going to rust out my entire furnace. That's why we keep it at 80% efficient, because if I get more efficient than that, it's going to create condensation. But comes the new units that are 90 plus. They're actually, most of them now are 98% efficient.
Just 98. That's pretty
98. It's pretty good. What happens is, instead of taking this hot gas and running it outside, what we do is we take that gas, and as it comes out of here, it's hot, we take it and run it through a secondary heat exchanger that's even smaller, with aluminum fins on it, that looks very similar to an evaporator coil. except it's made out of stainless steel so that we don't have to worry about the condensation rusting it out.
And that way you can get the last bit of warmth out of that.
And we also put a plate in the bottom that collects that moisture and we drain it out. And the combustion blower that we use that moves the gas, that wheel is now made of plastic because otherwise the acids in that moisture would eat away the wheel. So the wheel's now made of plastic. But we've taken so much heat out of that gas that we can use plastic because it's not going to melt anything. What? Isn't that crazy? This is a 90 plus furnace. I'm going to draw it out for you and then I will show you about how it works. All right, so this is a horizontal unit, so I'm going to draw it out like it is. I have my blower here. And normally we'd have our heat exchanger, right? Remember the ones we saw in the lab? The air blows across the heat exchanger. So what we're going to do is I'm going to move the heat exchanger here. So my fire is actually going to be here. And I'm going to burn my flames. Let me just do this first. So our furnace right now, we have the fire at the bottom, and then it pulls the draft through, and it sends the exhaust out, right? The cooler air touches the hottest part of the pipe first. And as the air flows through here, we're not picking up that much heat at the end anymore, right? You follow me? Yep. Fire burns here. What about if I did this? The fire burns here. And we pull with that fan the air coming the other way.
It'll be hotter on the bottom.
It wouldn't catch on fire, no. Because the fire's only burning this far. The fire's only burning that first section, but all this is gases. And we have a fan we're pulling the gases through. Over here, if I did it this way, the air is, say, 70 degrees. This is 100 and something degrees. We're heating the air very quickly, right? Well then, if my air is already warm and these pipes are cooler, am I going to have as much heat transfer by the end? No, they're going to have a balance point. But if I did it like this is cooler than this, right? And the air is still cooler than this. So we're going to have heat transfer from this to the air. Then we warm the air up. Now the air is touching this. We're going to have heat transfer. So now the air is a lot warmer, but this is still a lot warmer. We're still going to have heat transfer? I can get more heat out of this just by turning it this way. The fire's not really burning down. It's still burning across. I'm just pulling the gases down with that fan motor. I become more efficient. It's called a counterflow. So here, my heat exchanger, my burners are over here, and I run these tubes back and forth to a collector plate, and I collect it all at the end. Now those gases still going to be hot? Yeah, they're going to be hot. What I do is with that is take this plate and run it through another set of coils, back and forth, and they collect at the bottom. I've taken so much heat out of that, the exhaust is now cool. But this may only be, say, 80 degrees. But before the air even touches this, it's first touching the heat that I was once exhausting out.
Starting at the lowest area of heat and moving it across to the highest area.
Yes!
To get the most heat.
So my fan runs across the coolest part of the gases first, and it heats up the air, it preheats the air. Then the air touches this part, and it warms up even more. Then the air touches this part and warms up even more. Then the warmer air touches the hottest part of the heat exchanger, and it warms it up even more. And by doing this, I get 98% of the heat out of the air. Plus, that water is condensating inside. Condensing. For every 1 pound of water that changes state from a vapor to a liquid, how much BTUs of heat do I get out of that? 970. So I also get heat out of the condensation from it. Isn't that amazing?
Whoa.
It is. So here's the unit. On this side is the blower. It's moving air across. Where this plastic is, it says caution. It says hot Chod. I don't know who Chod is, but he's supposed to be hot, right? So that's my, yes. This is my secondary heat exchanger. My secondary heat exchanger is going to be made of stainless steel, and it's going to actually collect moisture. This piece is made of plastic, and if you notice, there's a drain here in the bottom. So I can drain that condensation. It's actually creating condensate in the winter. Then my air runs through my primary heat exchanger, and I heat the air up even more, And then I'm over here where my burners are. This is a 90 plus furnace. We have two heat exchangers, our primary heat exchanger and our secondary heat exchanger. We have to change our inducer motor to be plastic so it can handle the acids and the moisture. And also what's great about this is because I've cooled the air off so much, my exhaust is PVC, plastic pipe. Here's our exhaust, plastic pipe. I exhaust the air out of the house through PVC. And I have to use PVC for two reasons. One, it's cool enough, I can use PVC. But the second reason is that air that's coming out, that exhaust coming out, it's very moist, right? It's below dew point. That condensation in those acids would eat this away in no time. If I use this, it'd have to be stainless steel. Well, we don't want stainless steel. It's very, very expensive for stainless steel. So what we use here is PVC, and we force it. This is positive pressure. This fan isn't just allowing it to draft out naturally. The temperature's too low. We force it out to that PVC all the way outside. But wait, that's not all. By making this so efficient, I have two pieces of PVC. The other one's right here. Well, it's kind of blocked. Or right here on the side. I bring the air from outside that it needs to burn straight in. So I'm bringing air from outside, burning that air through here, and then the air is going straight back outside. It does not affect the pressure of the house at all. There is zero pressure difference in the house. 98% efficient furnace. Isn't that awesome?
Pretty good.
It is. So we're pulling air from outside, using that to burn, and then exhausting that air back outside through PVC. Where that exhausts, though, you need to be mindful of it. You need to follow the manufacturer's instructions. They will have one pipe that may face down and another pipe that faces up with a special cap on it. So you're pulling fresh air in, exhausting air out, depending on what they want. Some of the units that go through the roof, since I have two pipes, one's air in, one's air out, they go through a special pipe. So there's two pipes in one, and one pipe will be the exhaust, and it's built funny on the very top, and the other pipe is fresh air coming back in for it to burn. There's lots and lots of examples. I don't have a way of showing you all of them because there's 100 different ways of doing it, but follow the manufacturer's instructions. Where this exhausts to on the roof, it's usually not a problem, but I've seen people may take the exhaust, we're exhausting those gases out the side, and they exhaust them right next to our condensing unit over here. Our condensing unit's made of aluminum and copper and steel and painted metals. The gases coming out can be slightly acidic, especially with the moisture on it. So what happens, they exhaust those gases right out into a condensing coil, and it eats the aluminum away. It corrodes all the parts. You seen that, Jason? Yep. Yeah, that's a bad thing. You don't want the 90 plus furnace exhausting right next to that condensing unit.
Nice things.
That's why you can't have nice things. That and the dog peeing on it also. Or not put the cap on, yeah. They don't put the cap on, and the rain fills that pipe up when it rains.
You've got an upward facing pipe. You've got an upward facing pipe.
This is my pain.
Maybe you should look down instead.
You also need to make sure this drain pipe drains in a place where it can actually drain all the time. People take this drain pipe and run it outside. Well, there's a few problems with that. One, it's acidic, so it's going to kill all the plants out there. You have to actually put it through an acid neutralizer, so it actually neutralizes the acid before it drains. But think about this is running in the winter, and that drain line's running outside. Matthew, what's going to happen with that?
Oh, sorry.
Okay. Mr. Quick, what's going to happen with that? The drain line outside in the winter.
When we get into the snow, snow's going to evaporate.
What do you guys think is going to happen? It's going to freeze. Actually, liquid starts turning to a solid when it's below 32 degrees and we remove 144 BTUs per pound. It turns to a solid. Well, are you going to be able to get this water to drain outside when there's a solid plug outside? Nope. It's going to back up. It's going to trip a switch in here, or it's going to flood this. I've heard these run. They're like gurgling, where the fan is actually running in water. Glug, 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 glug. And they're like, this thing's not running right. Yeah, imagine.
Yeah, imagine so. There's kind of water in your furnace.
But these, when you drain them, you need to go through an acid neutralizer. You can't just drain them anywhere. So you want to go through an acid neutralizer first, and then you can put it in a condensate pump and pump it out. Or you can pump it into the city drain or wherever you need to go, but you have to go through an acid neutralizer first. So it neutralizes that acidity from that gas burning. Pretty neat, isn't it?
Yeah.
So the AFUE is annual fuel utilization efficiency. This is some of the most efficient units you can buy. These are really important. They need to be used here when you have a house that is foamed. Foam is some of the best insulation you can get. It not only is a good insulation, it also seals from air leaks. What's really great about foamed houses. Jason, do you like foamed houses, working in foamed houses?
Yeah.
Oh yeah, everybody I know loves it. A normal house you have insulation in the walls, and you put your insulation across the top. And it's either blown in or it's bats of insulation. And blown in's great insulation, but you have to like dig through it to find where your 2x4s are, and every time you work in it, you squish it down, it becomes less efficient. And the bats have air gaps in them, and they collect dust, and it's just ugh. A foamed house, they put foam when they're building it all down the sides, so it seals it from air leaks, as well as insulate it very well. And then what they do is they foam across the top of the roof. The heat doesn't even get into the attic, because that's where your insulation is.
That costs money.
It does cost money, but here is the place you shall have more foamed houses than anybody. What's nice is all your 2x4s are just exposed. There's no insulation across those at all. It's great to work in. Absolutely great to work in, because you don't have to worry about the insulation. And if the heat's not getting into the attic, is your attic going to be 150 degrees?
Oh,
No. It's going to be like 20 degrees warmer than the house. So if it's 70 degrees in the house, 7, 8, 9, maybe 90 degrees, maybe 80 to 90 degrees in the attic.
that's comfortable compared
Yes.
to what it could be.
These foamed attics, here, how hot do those foamed attics get? Jason, what do you think?
Close to 100.
Jason says close to 100. And that's when it's 115, 120 outside, right? That's pretty awesome. That's pretty awesome. So I loved working in these foamed attics. The problem, though, with the foamed attic is you have to think about the whole house as a system. If I put an 80% efficiency furnace in here, and I put my flue pipe outside, where am I getting air to burn the gas for that 80% efficient furnace? From the attic, right? Well, where is the attic getting its air from? Nowhere. There's nowhere for it to come from. The house is very well sealed. In the old days, we had vents on the side and vents in the attic, so it could get air from outside to burn. But now, once I put foam across the attic, I don't have any air to burn. And you end up with backdrafts and explosions and all kinds of really bad stuff. So when you have a foamed house, you must have a 90-plus furnace like this. Because a 90-plus furnace is going to have two pipes. One exhausting air out, and the other one bringing air from outside in. It doesn't need any air from the house to burn. So a 90-plus furnace needs to have that, and 80% doesn't. So here's a 90-plus furnace, one pipe out. Where is the air coming in it needs to burn? We call that combustion air, by the way. Where does that come in from? Yeah, the soffit vents, sometimes maybe even the roof vents. But in a foamed house, do you have any vents from outside in a foamed house? No, it's all sealed. So if you have a foamed house, you need one of these 90-plus furnaces. And I've seen people before that didn't understand that. And they had a 90-plus furnace in a foamed house. And the guy's like, oh, well, I can put this unit in for like $1,000 less. Okay. They put in a regular 80% furnace. You've seen that, Jason? Put in an 80% furnace. Where's the 80% furnace here going to get its air from if it's installed in this environment?
It won't.
It won't. And what do we have to have a fire? Fuel, heat, and oxygen. Well, if we don't have enough oxygen for it to burn from, that fire is going to be looking for a place to get the oxygen. And a lot of times it's going to be back drafting out, and there's no place for the draft to go either. It actually, I've seen it where it blew the doors off of an 80-plus furnace. Blew the doors off where the flames looking for oxygen.
I saw a flue pipe with the top, and then watched the top pop off and just shoot fire out of the top.
That's a bad thing. You don't want that happening.
It was pretty fun to watch.
These are things that are important. Even if I have an 80% furnace in a closet, I want to make sure that I'm getting air from outside the house, either through the attic and from the attic into the closet. But there was a job that me and a guy I worked with, we installed a unit, but what he used to do was on the vent pipe, and this is a closet, so it's upflow, he would take the vent pipe and he would push it up, and he would do all the work on the unit. Well, this one day he pushed it up, everything was fine, he was doing work, and the vibrations of the work he was doing caused that vent pipe to come back down. And it had a bit of a sharp edge on it, it was just metal, and it chopped his finger almost off, I can't remember which. I just remember it being blood everywhere and having to drive him to the hospital. So we finished up the job, but mine wasn't quite where it needed to be. So what happened was we didn't put the combustion air in there. We had to have vents in the closet that go into the attic. And the attic needs to have vents that go outside, like this one does. That's called combustion air. Well, we didn't do that. And what happened was when the furnace fired up, it couldn't get enough oxygen, and it actually blew the door off into the other side of the wall. Kind of got in a little bit of trouble for that one. Never forget that again. We need air for the furnace to burn. This 90% furnace is easier to install. It costs more. It's got more moving parts, but it's more efficient, and it's easier to install because it brings the air for it to burn from outside. And then it takes the air that it's burnt and sends it back outside. I don't have to worry about that combustion air. Yes?
So say money just was not a factor and didn't exist. Is there any reason to install not that? A unit that is less?
Well, if money wasn't a factor at all, then I would probably go with a ductless unit. For every room, have every room its own heat pump controlled system. Or if money wasn't an issue, then I would live somewhere that I didn't need air conditioning or heating. Yes. Yeah, I've been to some of those places.
Good question.
Yep. Hawaii, I think, is one of those places. I got a friend in Hawaii that he doesn't use air conditioning or heating.
Hawaii gets kind of uncomfortable.
It can get some humidity. What's up?
They just open the door.
Yeah, he didn't even have. He didn't even have. He has one room that's got doors in it, but he just leaves it all open. I'm like, yeah.
San Diego too.
So this is a 90 plus furnace. You need to know the AFUE of it, being a 90 plus and an 80%. How you install it, where you install it's different. If I install an 80% furnace, you're going to look in the furnace and see that there's louvers in the door. What are those louvers for? Louvers meaning holes. So it can get air for it to breathe. It needs air for it to breathe to have the fuel, heat, and oxygen. This 90 plus furnace, this was donated to us. We don't have the doors, but we don't have the doors on here at all. But if we did have the doors, they would be solid because they don't need louvers. It's getting its air from where? Outside. Now, even if it has louvers in the door, it still gets its air from outside. It just gets its air from outside the furnace, which gets that air from the closet. The closet gets its air from the attic. The attic gets its air through the soffit vents from outside. So either way, the air still comes from outside. This guy says, hey, let's bring it directly in from outside and send it directly back out to outside, and we don't have to worry about depressurizing the house.
About murdering people.
It's great. I love 90 plus furnaces. Even here in this climate, this is what I would prefer to install. I would prefer to install these. They are a little bit more expensive though. But they work great. I think they last longer, especially in this environment here. They will handle starting and stopping better than the other one will because they can handle the condensation. If I start and stop this one and don't give it enough time to run properly, I can end up with condensation running back down the pipe. When you replace a gas furnace, you always want to look in this vent pipe. And here is aluminum. And you want to make sure the aluminum's in good shape. I've seen people install new furnaces and they use the old pipe and this is all corroded up inside of here. So you always want to check that flue pipe. Make sure it's in good shape. Questions? Comments? Concerns? Concern, yes, sir.
I was just thinking about what matters.
Okay. So what we're going to do next is we're going to go out to the lab over here that the units are actually in the attic. There's one that has a vent pipe going up through the roof that's already hooked up. I want you guys looking at that vent pipe, seeing how it goes up and out. Look at it, see if you can determine what efficiency it is. And look at the other one to see how you would hook it up. Look at the drip leg in it to see how the drip leg's done. Look at the gas flex, see how it's done. Take a look at those furnaces and also go into the lab and take a look at those furnaces. See if they can identify any problems with those furnaces. Does that sound good? What time is it? 11. Great, so we got good. So go do that next. If we have some time, we'll add combustion analysis. We may not have time for it though.
No, I keep getting sent drop-offs from Midvale, Utah. It's like, I don't want to go to Midvale, Utah.
Why? 'Cause it's too short? Too tall?
No, I don't want to.
That's what I was thinking of.
Are we gonna film like a lab portion in here?
I was like,
We can try.
Okay, it's up to you if you think.
Let me show you what they're doing.
Okay. So I'll leave this on you then for whenever
Okay.
you're ready for that. Just let me know when you're ready.
Sure. Oh, I should set that on. What?